So what's the first thing I need to do to find the midpoint of segment AB? Jimmy? Okay, so if I wanted to find the x-coordinate of the midpoint of AB, then we're going to add up the x's, which would be what? Here, let me be a little bit clearer with what I'm doing here. So we're going to find the midpoint of AB. So the x-coordinate of our midpoint is going to be what? Tell me how we get it, Jimmy.
-3 plus -1 is -4 divided by 2.
Okay. And how about the y-coordinate? Go ahead, Jimmy.
And 0 plus 6 divided by 2, which is 3.
Okay, so what is the midpoint of segment AB? So the midpoint of segment AB is -2, 3. I'm calling it M just so we know that that is the midpoint of that segment. So the midpoint of segment AB is -2, 3, and then you can transfer that onto your graph. I'll give you a couple more minutes here to finish up. Don't forget to do everything that I ask you to, including connecting the midpoints. And when you connect the midpoints, I wasn't extremely clear about it. I want you to draw a quadrilateral when you do that. A simple quadrilateral, not a complex.
With a complex quad.
All right, so we found the midpoints for each of those segments. Those are the segments that are making up quadrilateral ABCD. So let's transfer that onto a graph here. Let's start by just plotting the points, and we want to go ahead and label the points also when we plot them, so that we know which one's which. So just real quick, I'm just going to call on people randomly here. I want you to tell me where to go to put the point. We're going to start at the origin and go which way. Kate, can you tell me where to go for point A? Okay, good. So there's point A right there. How about point B, Carly? Start at the origin and go
left. V1.
Uh-huh.
And then up 6.
Okay, good. So we go left 1 and up 6, and we get point B there. Okay, Dustin, how about point C?
Go to the right 5 and then up 4.
Right 5 and up 4. I think I counted right there. There's point C. And Megan, how about point D?
You go to the right 1 and then down 6.
Right 1 and down 6, so we get right there. All right, and then we'll connect the dots here. I can do that. You don't really need to help me with that, I don't think. I hope. So we get a quadrilateral that looks something like that. Do you agree with it?
Yeah.
Does everything look okay there? Okay, now let's plot the midpoints. So looking at what we got earlier from the work we did earlier, Brittany, what was the midpoint of AB?
-2, 3.
-2, 3. Okay, and where is that going to be, Brittany?
Left 2, up 3.
Left 2, up 3, and we get a point right there, right?
Yeah.
Okay, so there's the midpoint of AB. Cody, where was the midpoint of BC?
2, 5.
Okay, which would be where?
Right 2 up 5.
Right, 2 and up 5, and we get that point right there. Okay, Macy, Copeland, how about the midpoint of CD?
It's 3, -1, so you go right 3 and down 1.
Right, 3 and down 1, we get that point right there. Okay, and Jimmy, go ahead. Midpoint of DA,
-1, -3.
which would be where?
Left 1 down 3.
Left 1, down 3. Okay, so the last thing I asked you to do then was connect those points, right? So connect all the midpoints, midpoint of AB to the midpoint of BC, midpoint of BC to the midpoint of CD, CD to DA, and then the DA back to AB. The reason, well, first of all, we found the midpoints just for midpoint practice, But the reason I wanted you to connect those midpoints is because we get a certain kind of shape here. What kind of shape is that, Cody? It is a parallelogram. Later on, tomorrow, we're going to talk about slopes, and we're going to show how we can figure out if a shape is a parallelogram based on the slopes. Can somebody convince me that this is a parallelogram, that it has to be a parallelogram? Sam?
Okay. So, I was going to say it all lined up. Don't ask me.
Okay, I'm sorry that I called on you.
Yeah, kind of.
Jimmy?
This is the y coordinate.
Oh, no, I got this.
The y coordinate?
Yeah, the
Of-
6 and -6 are the same. The opposite.
Sam?
Okay, so from one point to the next, like that. So from the BC thing to the AB one.
Okay, so this one here
1,
to
2,
this one here.
4 squares
4 over and
and 2 up.
2 up, okay. And how about here?
Same.
4 over and 2 up. So essentially what we could do is we could take this shape right here and move it anywhere on the graph, and it would go up 2 and right 4. And the reason I'm going up first is that's the way we do slope. So we'll talk more about that later. But if I take this segment here and move it anywhere on the graph, as long as I don't twist it, if I twist it, then it's not going to be parallel to where it started. But as long as I don't twist it, it's going to stay parallel. So I can move it down to where this segment right here is, and it's still going up 2 and over 4. So those two lines are parallel. The same thing with the other two sides. For this side, you would go down 6 and right 1. On this side, you would go down 6 and right 1. And that's enough to convince me that those two are parallel to each other. So we do get a parallelogram. Do you think it's a coincidence that we get a parallelogram?
No, because you would have picked something else if it was coincidence.
There aren't a whole lot of coincidences in this class, are there?
No.
This is actually kind of a cool thing. It's not immediately obvious why it happens, but if you pick any 4 points and make a quadrilateral out of it, then you find the midpoints and connect those, it's always going to be a parallelogram. So ABCD is not a parallelogram, is it? No. But if I connect the midpoints of ABCD, it's always going to make a parallelogram. It's kind of cool, I think. You don't have to think so, but I do.
Kind of cool.
Yeah. All right, moving on. So yesterday we did midpoints. Today we're going to do distances. We're going to talk about distances. Just like we did with midpoints, we're going to talk about distance on a number line first, and then once we kind of get the hang of it on a number line, then we're going to switch over and do it in 2 dimensions, just like we did with midpoints. So on each one of these, we want to find the distance from point A to point B. So let's just take them one at a time here. Looking at that first one, what is one way we could find the distance from point A to point B? I can think of 2 pretty good ways and lots of other not as good ways, but valid ways of finding distances here. What would be one way we could do it, Sam?
We could count the dashes to the next one.
Okay, Sam's exactly right. So one thing we could do is start at A here. Let's try to use something a little more appropriate. Okay, start at A here. Pretend like you're the Easter Bunny and just hop along here. And 1, 2, 3, 4, 5, 6. So what's the distance from A to B?
6.
What are you laughing at? So what's the distance from A to B? How do I know it's 6?
I'm going to draw the Easter Bunny on this.
You counted 6.
I did count 6. Does that mean that in this one right here, the distance from A to B is 1, 2, 3? No, it's not. Okay, so yesterday's opener, we talked a little bit about scale. The scale on these 2 number lines is different. The top one has a scale of 1, which means that every space that we go has a value of 1. That's not true on the second one, though. So how could we figure out, going 3 spaces on that second one, how could we figure out what the distance is going to be? It would be 3 spaces times 5, because each space has 5 units. Okay. So that means that the scale here, the scale is 5. How do we know the scale is 5?
Because it's-
Between 0 and 5, there's 5 points.
Yeah.
And those are the first two.
Yeah, exactly. The space between these first two hash marks is 5. Okay, so we know the scale there is 5. So the distance, I'm going to go ahead and write this out here. The distance is going to be 3 spaces times 5 for each space, which is going to be 15. Okay? The first one, all we had to do for the distance is just count the spaces, and that's it. So how about the third one? Sam.
Guys, we're gonna do first is divide 324 by 3.
Was that a question?
3.
Okay, good. So the first thing we're going to do is divide 324 by 3. Why would we do that, Sam?
Because to get from 0 to 324, you have to do 3 jumps.
Okay, so we're trying to find, when we do that, when we do 324 divided by 3, we're trying to find the, starts with an S, scale. We're trying to find the scale. So 324 divided by 3, that's a pretty easy one, I think. That's 108. So the scale on this is going to be 108, which also means that this hash mark right here has a value of 108. What does this hash mark right here have? What's the value of this one? Or the coordinate?
Negative 108.
Negative 108. How about this one? Negative 216. How about this one? Negative 324. How about this one?
Negative 432.
Good job, Evan. I'm impressed. I'm gonna go ahead. I'm gonna go ahead and write a couple of these down here. Negative 216 and negative 432. Is that what you said, Evan? So I can use those values. We'll talk about that in a minute. But what's the easiest way now to find the distance? Well, how about this?
Yeah.
So the distance is going to be 2 times 108, which is
Just add negative. And now?
216. So that distance between A and B is going to be 216. So that's the first way that I mentioned to find the distance between 2 points. Count the number of spaces, and then what? No. Count the number of space. Multiply by what, Macy? Yeah, multiply by the scale. So count the number of spaces and then multiply by the scale. The problem is, a lot of times on a number line, we're not going to have a scale. We might just know where the 2 points are, and that's it. So those might be the only marks on the number line. So I'm going to erase all of this.
Oh, come on. I already wrote down.
It's okay. You have the right answers. But let's say we didn't know that all of these points are in here. We don't know how many spaces there are. What would we need to know if we didn't have all these hash marks here?
What they were.
Cody? Yeah, we would need to know the coordinates of those points, right? So we would need to know the location. What is the location of point A here? What's the location of point A?
Negative 4.
Negative 4. Now, to find that, we actually do need those hash marks, right? But let's say, for the purposes of this problem, that the only thing you're given is that A is at negative 4 and B is at 2. How could we find the distance from A to B now? Cody? Which is what? Is that the same answer we got earlier? Yeah. So what Cody did there is what? Cody, explain why you did 2 minus negative 4. So you did what? What operation? Yeah. We just took the coordinate at B and subtracted the coordinate at A. Okay. Is that going to work for all these?
Yes.
I don't know. Let's see. Actually, I do know. What is the location of A in the second one? Negative 10. So using Cody's formula here, do we have to do B minus A? Could I do A minus B?
Sure.
Let's try it. Let's see what happens if we do A minus B. So negative 10 minus 5. What do we get for that distance? Negative
Not what we
15.
got.
What's that?
Not what we got.
Okay, that's not what we got, but it's kind of close to what we got, isn't it?
Yeah.
It's the opposite.
It started
What we started talking about this very early in the school year, like back in August or September. When we measure distances, what do they always have to be? Positive. So there's a formula, and there's different ways to write it, but there's a formula for distance, and it's exactly what Cody said it is. You subtract the coordinates, subtract the locations, but we also need to make sure it's positive. And what's a way to make sure that this is always going to be positive, no matter which one we subtract first? Well, we could always do the bigger minus the smaller, but what if we don't know which number is bigger? I know it sounds crazy, but what if we're using variables and we don't know which variable has a bigger value?
You just change the final answer to positive.
Kyla? Absolute values. Perfect. So the distance between 2 points is the absolute value of the difference between the 2 points. Difference means we do what? Subtract. Okay, so if we just throw those absolute values in there, now all of a sudden we have the answer that we got earlier. Right? Okay, cool. I'm not going to finish that because I ran out of space, but you know what it is. Evan, you said this is negative 216, right? And this is negative 432? All right, cool. So how are we going to find the distance between those just knowing the coordinates of those points? Sam?
Okay. Negative 432 minus 216. Absolute signs. Remember. Yeah.
Okay, good. Now, we could make this a little bit easier on ourselves if we know negative 216 is bigger than negative 432, which it is, right?
Yeah.
Negative 216 is bigger than negative 432, right? Yeah. So if we know that one's bigger, then we can do the bigger minus the smaller. We don't have to worry about the absolute values, but we can. It really doesn't matter. Negative 432 minus negative 216 is the same thing as negative 432 plus 216, which gets us to negative 216. And then when we take the absolute value of that, we get what? 216. Does that make sense? Okay, so do it without the number line. We want to find the distance between point A, where x equals 2, and point B, where x equals 9. I'll give you a minute to... How are we going to find the distance between A and B here? Malik? Aaron? Aaron, you said it, right? Okay, so what are we going to do?
B minus A, so 9 minus 2,
Yep,
7.
the value at B minus the value at A. So the distance between these 2 points is 7. We don't even have to know what it looks like. We don't need the number line to determine that. So I would like you to copy down the rest of the problems here and go ahead and do those real quick. For part B, how do we find that distance? Who can help me out with it? Jimmy, go ahead.
12 minus 3.
Okay, we can do 12 minus 3. And what do we get?
9.
Why are you laughing?
You said 8.
Who did?
Yes.
All right, how about part C? Nancy.
And say
1 minus negative 2, which is? Okay, good. Part, what are we on? D? Malik.
15 minus 9.
Okay, why'd you switch it up? And all the other ones we've done B minus A. Why are we doing A minus B here?
Because 15 bigger than 9.
Yeah, as long as we do the bigger number first, take the bigger number minus the smaller number, we don't have to worry about the absolute values. And what do we get there, Malik? Okay. And the last one? Vishal?
12 minus 4. Or negative 12.
Negative 12 minus 4? I don't think so. Minus negative 4, right? Okay, which is the same thing as negative 12 plus 4, which gives us negative 8. Is that the distance? Yeah, so in this case, we need to throw the absolute values in here because we know it has to be positive, and so we get a positive 8. And technically, the absolute value is in all of these. We just didn't need it because they were all positive, right? So as long as we get a positive number, we don't need the absolute values. Any questions about this one? Sam?
Oh, it's negative. Okay. Didn't see it at first. I don't know.
Oh, okay. All right. So, like I said, we're going to make it a little bit more complicated now. And we're going to look at distance in 2 dimensions. Now, yesterday, when we did the midpoint, and we added a second dimension, it stayed exactly the same except we had to find the midpoint twice. We had to find the midpoint along the x-axis and the midpoint along the y-axis. So let's do that here and see what happens. So let's say I want to find the distance between -5 and 5 on the x-axis. So that's this distance right here. How do we find that distance? Huh? Add them?
Multiply
5
-1.
5 plus -5 is 0 times -1 is 0, so the distance is 0, according to Sam's formula. I don't think we want to add them. We've been doing it now for 2 examples. How do we find the distance along a number line? We subtract, right? So this distance right here is going to be 5 minus -5, which is 10. Okay? So the distance along the x-axis is going to be 10. Okay, how about along the y-axis? If we're going from 6 on the y-axis to 1 on the y-axis, that's this distance right here. How are we going to find that distance? Don't write this down yet, because it's going to get in your way of a picture you're going to draw later. Sorry. How would we find that distance? Subtract. Everybody was thinking it, right? So we're going to do 6 minus 1, which is 5. Now, if we compare this to what we did yesterday, we get a distance along the y-axis and a distance along the x-axis. Can we just combine those and say the total distance is 15? No. Why not? But we did it yesterday, and it worked, right? What? So the total distance between those 2 points is 5. Maybe.
We don't know. Yeah.
It's possible.
Don't have to subtract them. So let me put those distances in this picture in a slightly different place. So I'm going to clear this here, and I am going to,
Hold on, I know this one.
you know it?
Yeah.
What are we going to do?
You're going to just slide it down on the line.
Like that?
Oh, no. No, like you got to slide the whole line down.
Oh, no, we don't want to do that.
Okay, never mind.
Good idea, though. I like the thought.
Try.
Let me move this a little bit here. Okay, so we found the distance along the x-axis, and that distance was what? It was 10. Where do we see that distance of 10 in this picture? That right there, right? So that distance was 5 minus -5, which is 10. Okay, how about the 5? Where do we see that 5 in this picture?
On the side.
On that left side over there, right? So this vertical line here is going to have a length or a distance of 6 minus 1, which is 5. So I think this picture makes it much clearer that the distance is not 15. Because if I want to start here, right there, and I want to go to there, I don't have to go down 5 and then right 10 to do it. I just want to go in a straight line. So how could we find the length of that line right there? Sam?
Pythagorean theorem.
Yes. Why?
Because when you have 2 sides, so just get a nice
2 sides of a,
triangle.
what kind of triangle? Yes.
Right triangle.
So since I drew a vertical line and a horizontal line in here, what we've created is a right triangle, and now we can do the Pythagorean theorem. In fact, if I hide, I'm going to go ahead and draw this line in here. If I hide the rest of this picture, what we're trying to find here is that distance right there. We'll call it D. I'm going to hide that picture there. If I gave you this problem 3 months ago, you would have done it without a problem. If I told you that this right here is 5, this right here is 10, find D, what would you do? Set it up for me. Anybody?
Okay.
Evan, do it. Go.
5 squared plus 10 squared equals D squared.
Okay, good. And what is 5 squared?
25.
And 10 squared?
100.
And D squared?
125. Oh, D squared.
So we get 125 equals D squared. And so D is equal to the square root of 125. And I'll save you a little time here. This is something you're going to have to remember how to do. But how do we simplify that?
Square root.
Factor it and then
Take it out.
take what out?
House. Then doubled.
Yeah, we look for pairs and the pairs get to go outside of the house or outside of the radical jail as some people like to call it. So we end up with D equals 5 square root of 5. So the distance between those 2 points we can find by just doing the Pythagorean theorem. Okay? So let me put that picture back on there for you. And I would like you to draw that out. Finding that distance from the point at negative 5, 6 to the point at 5, 1. So the idea here is we're going to generalize that process, what we just did, so it's going to work for any 2 points we want to pick. So what's the first thing I need to do here, Sam?
I got it. Hold on. You got x minus x. And then, yeah.
To get what?
You don't know yet. Chill. I got this. X minus x. Parentheses squared plus y minus y. Parentheses squared equals c squared.
D squared. We'll use D for the distance. Okay, Sam's actually right. He's skipping ahead. He's skipping a few steps here. So what we want to do is we want to build a right triangle. So to do that, we're going to drop a vertical line from that point, and then draw a horizontal line and get a right triangle in there. So this right triangle now is going to allow us to use the Pythagorean theorem. Now, Sam said x minus x, and Sam, when you said x minus x, what length were you finding in this picture?
The bottom one.
Yeah, so this distance right here, we can get by subtracting those x values. Now, in this particular picture, x2 is bigger than x1. Since we're generalizing, though, since these are just arbitrary points, we don't really know that x2 is bigger than x1. So we have to be a little bit careful here. Right now, we'll do x2 minus x1 to get that distance. But understand, that number might be negative. If x2 is actually smaller than x1, that number would be negative, which would be a problem, wouldn't it?
I put the absolute value.
Okay, we could put the absolute values on, but we'll talk about later. We're actually not going to need them. I'm not going to put them in yet, and we'll talk about why in a minute. Okay, if we want to find this distance here, that vertical line, what numbers are we going to subtract? Cody? Yeah, exactly. y2 minus y1. Now, in this particular case, y1 is actually bigger than y2. So if we plugged in the numbers that we had, for example, in that last example, we would end up with a negative number here. But what's the next thing we're going to do?
Square.
We're going to square it. What happens when you square a negative number? It becomes positive, doesn't it? So let's say, for example, x2 minus x1 is negative 4. What's the absolute value of negative 4? Positive 4. Okay, what's negative 4 squared? Positive 16. What's positive 4 squared?
16.
16. So does it matter if this number is positive or negative? No. If we get a negative number here for this distance, when we square it, we end up with the same number we would have gotten if it was the positive. Does that make sense? So we don't even need the absolute values here, because even if we get a negative distance, it's going to turn into a positive when we square it. All right? So now what we need to do is find D. Find the length of what is now the hypotenuse in our right triangle. So I'm going to call this D. And who can set up an equation to solve for D? I need an equation to solve for D.
It's kind of risky there. Ghost goes out of nowhere.
I need an equation to solve for D.
I already gave you.
You did. Just say it again.
Kill me. X minus X.
Okay, so the order that we wrote it was x2 minus x1. For the reasons we just talked about, it really doesn't matter what order, but we'll always do x2 minus x1 and square it. Okay.
Y2 minus Y1. All of that squared.
Are the parentheses that I'm putting in here important?
Yes, very.
Okay, good. They are very important. I like that you qualified that.
Equals D squared.
Perfect. Leg squared plus leg squared equals hypotenuse squared. Now this is really close to what we're going to call the distance formula. Now this isn't quite a distance formula yet because we don't have the distance by itself. What can we do to get D by itself here? Take the square root. So the distance formula is really going to be the square root of all of that. So let me take a second here to write it down. So the distance, D, is going to equal the square root of that whole thing right there. And that formula comes from stuff that we already knew how to do. It comes from the Pythagorean theorem. So here's your distance formula. So let's look at some examples. I've got the distance formula up at the top. You also have it on your paper there. So what I want you to do is plot the 2 points and then find the distance between them. And we're going to do this, this particular example both ways. We get out of here in 4 minutes, don't we? Okay, so let's do this quickly. I know, right? So 2, 3... So I want to find the distance between those 2 points, which is the same thing as saying the length of that line segment right there. So what could I do? Let's use the formula first. Who can just plug stuff into a formula for me?
Sam.
Go ahead, Malik.
D equals 7. I mean, it's negative
Yep,
1.
you're right. Oh, yeah, I'm sorry.
Negative 1 minus 2 and squared plus
Okay.
7 minus 3. Squared.
Squared. Good. What's negative 1 minus 2? What's negative 1 minus 2? Negative 3. So we have the square root of negative 3 squared plus, what's 7 minus 3? 4 squared. And then what is negative 3 squared? 14 squared? 4 squared? Not 4. 14, 16. I'm struggling, sorry. What's 9 plus 16?
25.
And the square root of 25? Now let me show you something kind of fun here. What is the distance right here? What's 7 minus 3?
3 or 4? 3.
7 minus 3 is 4. Thank you. What is 2 minus negative 1? 3. So what kind of triangle is this? It's a 3, 4, 5 triangle. So you could use the formula here, but it's a lot easier if you just find those distances in the graph in the coordinate plane, and it's a 3, 4, 5 triangle. Now, it's not always going to be one of those Pythagorean triples, but if it is, it will save you a lot of work.